Please be kind.
All right, so good evening, everyone. This is Paul, NO0T with the Front Range 6-meter group. Welcome to our Zoom call tonight. And if you're listening on YouTube, thanks for joining us. Tonight, we have the honor and pleasure of listening to Scott McIntosh, Dr. Scott McIntosh from the National Center for Atmospheric Research near Boulder, Colorado. And he's going to talk to us about what the sun is doing in terms of cycle 25. So, Scott, could you take over and show us what you got?
Well, I figured when I was looking at the dates of this what's going on? Can you see it okay?
Yeah.
All right, so this is going back to retro graphics, right? So when I looked at the dates of this, and I realized it was 2 years ago that our Terminator friend happened, right? So it's kind of funny now that we can come back and contrast. I remember certainly discussing with Frank at the time, being eager for this thing and talking to you guys through the whole episode of this whole idea of what the Terminator was and when it was going to come, and the fact that we didn't get it right. But it did arrive, and it's kind of performed as anticipated, I guess. So I'm gonna kind of walk through a kind of a status update. I don't have the big huge deck of slides, so I don't have any of the retrospective stuff. So if you're new to this, I apologize. I'm just gonna kind of dig into an update, and but feel free to ask questions after if there's huge glaring holes that I've missed. So when we were looking at this, Paul, I don't know what the anniversary of our first date was, but I think we're probably at least 2.5 years ago, which is kind of amazing. And my credit to you for taking the risk on a stupid guy with a stupid accent talking shit. So it's really been my privilege to share this with you guys as an experiment as we've moved along. And kind of this picture says 1,000 words. And it kind of expresses some of our thinking back in the 2019, 2020 frame, is that cycle 25 presented an opportunity possibly to present a paradigm change, because some of the work that we've discovered, some of the things that we've discovered over the last decade or so, would appear to contradict the prevailing wisdom of what the sun's internal magnetic machine is doing, and how that of course, how you test that is by measuring the manifestation of certain solar phenomena such as sunspots and things like that. So this is a slide for a presentation I gave up on Capitol Hill back in May, I guess, and it was to a bunch of space weather professionals, people that run federal agencies, people that operate spacecraft in the federal and private sectors, and they were kind of interested because, of course, now and more than ever, there's a lot of objects in low Earth orbit that have low voltage devices that kind of don't like space weather. So, and most of them had been designed in times, or could at least kind of conceived in times when solar activity had been tailing down for the last 30 years. And so they were kind of hoping that space weather and solar activity would continue to tail down. Right. So you look at that image and you can see, there's a clear downward trend of about 15 to 20% per decade. Wow, I think it's going to continue. Well, maybe not. Okay. So, 2 years have passed, or several years have passed now. At the time, Sunspot 25 was going to kick off, but the question was, what would it do? What would it present? And of course, it's kind of relatively well documented. At the time, there's a group of my peers meeting in our building. Actually, this is documented in a rather funny article written in Science magazine, that at the time in 2019, in our building in Boulder, a group was convening to talk, prognosticate on solar cycle 25, what amplitude it would reach, when it would reach that peak amplitude, etc., etc. And at the very same time, my group and I, or my peers and I, were sitting in my office mulling over this result that looked like it was anything but what the group down the stairs were saying. So just to contrast, at the time, so this is circa 2019, the original forecast was published in 2020. It's in red there. It's a kind of Gaussian envelope. It's just a guess, right? An approximation. Green is the mean of all time. So of the previous 24 cycles, green is the average. And then blue was that forecasted by my colleagues and formally trumpeted as what the sun would do in cycle 25. Okay. That was in 2019. A lot of water has passed under the bridge because, of course, our prediction of 2019, 2020 was waiting on a specific event to occur, right? And that event we dubbed the Terminator, and what it basically is, and I'm sorry, I should have added the one beautiful context slide that Frank and I published last year. Basically, the sunspot cycle is a manifestation of the underlying 22-year magnetic activity cycle. And what we think we detected, or what we thought we had detected, was an event where basically the 22-year magnetic activity cycle ends. And as it ends, the sun basically springs to life and a new sunspot cycle is born. The bands of these magnetic cycles overlap one another in latitude and time. But basically what happens when the Terminator event happens is that old magnetic cycle catastrophically dies at the sun's equator. Right? As it dies at the sun's equator, activity springs to life at mid-latitudes. We can get into the why of that later, if anyone's game. But, this wasn't our first hurrah. This was not the first event we'd seen, but it's the first one that we'd tried to predict when it was going to occur. So like I said, so in 2019, our forecast was dependent on 2020 arrival of the Terminator. I'll get into that in a wee bit. It didn't arrive in 2020. It arrived about 16 months later on. And that meant that we had to revise our forecast, but we'll get to that in a wee minute. So there's the data as of a year ago. So here you go. This is a measure of the density of small objects on the sun. You can see the Terminator event happened around the turn of the year. You can see how things abruptly changed at the mid latitudes, but also at the equator. And the sun has slowly trundled on its way ever since. Okay. Now those bands, you see them slowly migrating towards the sun's equator. It's part of a natural progression. 5 to 6 years from now, we'll be watching for the next Terminator event. And also in the meantime, we'll be watching the next sunspot cycle, the breadcrumbs that form the next sunspot cycle start to appear. In fact, making a kind of crazy bold prediction, I think we'll be able to see those probably by the middle of next year. So we'll be able to see, kind of prognosticate about what's going to happen in the mid-2030s. So anyway, nobody cares about that stuff. So 2 Terminator events. So there's one. Here's another one and another one. So this is the lifetime of the Solar Dynamics Observatory. You can see that this event that happened in 2021 is not a fluke. You can see the growth of activity at mid-latitudes in 2011, as it was at the time, and then again in late 2021. So again, the data continues on its merry path. I taunt my colleagues often by presenting a chart that I made in 2012, where my then 5-year-old kid drew straight lines on it to predict when the bands would end. She actually did very well. She actually did better than I did with math. So anyway, let's not get into that. So there's 3 Terminator events. So one from 1997, 2011, and then again, okay, in 2021. So these are no fluke. You can actually see in this plot the very significant spatial temporal overlap in these bands. This isn't the best way to visualize that, but it is certainly clear. One of the things that's most interesting about this is that if you think about it, if you contrast this plot with a plot of the sunspot number, which I'm not sure I have, not in this deck. So that's between, let me see if my axis comes up. So between, let's look between 2008 and 2010, and between 2017 and 2020, you can see that there's 4 kind of systems present. But that's exactly the time when the sun's not making any sunspots. So it appears for this event to happen near the sun's equator before you could make sunspots. Okay, so there's some major internal connectivity going on. And I think that's the primary contrast that we have between these kind of legacy models and what we're talking about is the fact that the big magnetic fields inside of the sun, which are huge, know about one another. Okay, we can talk about that a wee bit later. Again, the death of a cycle, boring stuff. This is longitude. So now I've gone from latitude versus time to longitude versus time, just to mess with your head, right? So these are now vertically, it is activity as a function of longitude around the sun with time running vertically, right? So again, what you're kind of looking for is times of darkness. So times where activity is very low and then it kind of springs to life, right? The kind of cool one here is the middle panel, where you see activity on both sides of it and then it's dark. So there's just nothing going on, right? For whatever reason, the sun is not emerging large-scale magnetic field there anymore, so therefore it's not making spots, but that's happening at mid-latitudes, right? So there's some really weird internal connectivity going on. There's just the continuation of that data with time. The mildly interesting thing about this data now is that you see the diagonal lines that appear in the data. You use the same technique to analyze weather patterns over the Earth to predict when lows and highs are going to occur, right? So it's exactly the same methodology for predicting global scale weather patterns. So basically what I'm saying is that the sun's magnetic field exhibits weather-like characteristics, right? That's something that nobody's really pursued or identified. We observed this back in 2015 and reported it as being the signature of we call it a magnetic Rossby mode. But a Rossby wave are these global scale waves that carry the planetary weather, if you like. So the sun has the same thing. So the fact that we were wrong in 2019 and kind of mispredicted when the Terminator event would happen means that we had to revise and correct our forecast, right? So the 6 meter folks, this is old hat to them. They've seen this plot a bajillion times. And because, so what this does is it presents a kind of statistical analysis of the 24 preceding Terminator events to the ones I've shown you, and their impact on the upcoming sunspot cycle magnitude. And you see, it's a pretty nice linear relationship. But with the change to late 2021, it means that sunspot cycle 25, instead of being possibly in the top 5 of all time, which if you care to go back and look at the headlines at the time, that was what was being touted. We always published the caveat that we needed actually to observe the Terminator before we trumpeted that. But anyway, it slides down towards the mean. So the mean is that black dot with the big M in it, right? You'll notice also that it's still almost a factor of 2 greater than the magenta line, which is the NOAA prediction, okay? This is the consensus. This is the community consensus prediction in the magenta vertical line there. So we're still almost a factor of 2 off. One of the things that is fascinating about these Terminator events, and and that we've been trying to plug our colleagues into is the fact that it's not just a local change in the sun's magnetic field, it's a global change in the sun's magnetic field. So you see it as a function of latitude, you see it as a function of longitude, and it's almost instantaneous. And I have to maneuver you guys a second. I need to turn this off. Can you see the far right hand side of that plot? Right, so the terminator happens in the very end of 2021. This is the amount of cosmic rays that hit the Earth's atmosphere, right? So if you think of it like the sun's magnetic field like an umbrella, and you're standing in Sucky Hall Street in Glasgow, so the Irish colleagues will probably get this, right? And it's pissing with rain. Because, you know, when you're in Scotland, it's almost always pissing with rain. And you throw up your umbrella, you're not wet anymore. Same thing happens with the sun's magnetic field. So the sun's magnetic field acts like a shield, like an umbrella, and basically deflects a lot of the cosmic rays that come from outside of the solar system in. And so you see this massive shift in the amount of these very energetic particles hitting the atmosphere. It's a beautiful illustration of how global the sun's magnetic field changes, but how abruptly. Just to illustrate the change, there it is. I think this plot is maybe only a couple of weeks old. So you can see that systematic long-term shift in the amount of cosmic rays hitting the Earth is real. It's not a fluke. It'll level out soon. But it will continue to go down maybe for another 6 months or so. So back to how it started and where we started, I think, Paul. So this is the same plot that I had earlier. Well, I had to revise it, right? And we revised it when the terminator was measured. Took us about a year to write the paper. It appeared January of 2023. We have the usual fun with reviewers on this stuff. Every paper takes a minimum of a year to get published. So some of them take longer. But, you know, compared to the red curve, which is ours, the green curve, which is the historical average, and the blue curve, which one's winning? Do we have it's a shame we don't have a upvote, downvote kind of thing going on here, but I think we're still doing pretty well. Frank, are you getting ready to go dance that jig? So when we calculated the 2019 Terminator, we made this plot. And this plot is basically how well, do you remember that relationship that I showed earlier between Terminator separation and upcoming cycle strength? Well, when you've got that relationship, you can actually go back into the data and reconstruct all the old cycles and see how well you would have done. Right? So those red dots are the predicted amplitudes if you just use that simple relationship, right? The vertical lines are the 1 sigma error bars. So it's not bad. It's not great. It actually underpredicts big cycles because there's not many of them. But it doesn't do too bad. So, but now let's put that in current context. So you can see from this that when you revise down that purple dot, or whichever color I made it in this plot, the present state of the system is moving itself into the error bar, right? So that gray shaded box. So we're doing, I think, within the errors, we're actually kind of on the money. Okay. Certainly better than the lower estimate. However, some of you may have noticed that in recent months, someone turned the spigot off, right? And this is one of the things that is also visible in the Rossby plots, is that the sun has this crazy oscillation. And if you look at this, you can see an oscillation that's about, in this case, it's about 8 months long. You can see that the peaks, as it reaches a peak, is about 8 months, and then it goes down, and then it comes back up, and then it goes down, and then it goes back up again. It's just in the middle of another upturn. And funnily enough, when the sun is in one of these upturns, we get X flares. No other time, right? What happened today? Anyone? Bueller? Big X flare. In fact, the biggest X flare of the season. So we know for sure that we're climbing back up. Whether we'll up to that 200 mark, I don't know. That'd be freaking awesome, to be honest. I think if we get up to the 175 level, I think we'll be still pretty happy. But it has turned down. But it's kind of interesting. So those in the 6 meter crew that have been following for a while know that with Frank, we kind of made a forecast of F10.7 based on or the 10.7 solar radio flux based on the statistical average since 1947 when you monkey around with time and only look at the Terminator. So you're looking at Terminator to Terminator statistics because you think that the Terminators basically create a clock for the sun, right? We can get into that a wee bit if you want. The nice thing about weather, for example, is that our planet takes 365 and a quarter days to go around the sun. Almost exactly, give or take a second or two. And that means that our calendar is very robust. For the sun, the clock isn't so robust. But probably the best thing we've found ever statistically to describe what the sun's doing is these Terminator events. They mark land. What's the right phrase to use? Like massive. They're landmarks in the solar chronology. And so if you start to use them to understand the statistics of what's going, guess what? Things start to make a little bit of sense. So with Frank's help, I guess probably almost 18 months ago, I guess, we decided that we were going to put one of these for the solar radio flux together. Because why? Because you guys like the solar radio flux to help you with propagation, right? So it was right about the same time I was talking to the 6 meter folks here. And so this is how things started. So the green blob is our forecast circa, I guess we developed this probably in the late end of 2021, right as the Terminator was happening. So once we knew what it was going to do, we can project forward guesstimate how long the cycle is going to be. We know the relationship between the sunspot number amplitude and F10.7. And here we go. Okay. So at the start of 2022, the data is in blue, right? So the monthly data is in blue and the daily data is in red. Then I'll take you on a little crash course through the rising phase of the cycle. It's looking great, right? And some of you, I remember last time, noticed the double hump, right? Paul, there was a little bit of conversation about the double hump in this. That statistically, F10.7 displays a double hump over time. That's true even if the sunspot cycle doesn't have a double hump. So there's a wee bit of a mystery in here. So there we go. Guess what? El Sol followed the path down. Right? We were not anticipating that. I remember looking at this plot a year ago going, that double hump's going to kill me. I don't know. What if it keeps going up? Didn't, right? So if you look at this, statistically, the green dots, 88% of them, the blue dots, the blue data values, 88% of them are within 1 sigma of the mean, which means that, we're accurate to pretty high percentage over a pretty long time frame, right? That's pretty damn good. So damn good that people in the Bay Area are really clamoring to use this data to help protect their satellites, right? So anyway, we'll get into that. So that's one thing. So we're testing statistics against reality. The statistics are driven by what we think the sun is doing. Maybe we're onto something. Now, about 2 months ago, I got a text from a friend that the NOAA website had suddenly changed overnight. Why? How had it changed? Well, it had changed because they changed their methodology in predicting the sunspot cycle, right? And this is what you get now when you go to their website. I should have plopped it up, but this was from December 1st. You can see the old prediction panel things in red. You can guess, I'll show you in a little bit, where ours sit. So I don't know if this is acquiescence to our forecast or not. I'll leave that up to you, right? Difference is that we've not changed ours since we locked it in. Now that's for the sunspot cycle. This is for F10.7. So we're like, so I don't know, they're using a kind of numerical prediction algorithm. It's not really AI. It's just looking at the current state and then projecting it forward by whatever with some function. I don't really know quite how it works. But, you know, our forecast looks robust relative to it, which is a kind of cool thing, I guess. The other thing that we've discussed in time is maximum timing, right? And some of you will know, because you're all probably more expert than I, that solar maximum doesn't always happen at the same time in the sun's two hemispheres, right? Which is often why you get multiple peaked sunspots cycles. The timing of those maxima are to do with, although not explicitly tied to, the sun's polar reversal process. So if I look at the top plot, that's your average sunspot number plot, right? Like I've showed a jillion times already. Haven't showed this panel B here, which is from the Wilcox Solar Observatory down at Stanford. They have these very large diodes. And for the last almost 40 years, maybe 50, 40, I can't remember, they've measured the polar magnetic field of the sun. Okay. Red is positive, blue is negative, and you see how it's almost shaped like a fish. It goes up, it's like a helix, right? Because the poles flip. One's the northern trace, one's the southern trace, and they flip. Okay. On top of that, of course, we've messed around a little bit and looked at the statistical average again using our terminators. About 5 years ago, we identified that the polar magnetic field also is keyed by the terminator. So you can form very good statistics of it. Maybe not in amplitude, but certainly in its repetition. And so we were able to kind of forecast based on where things were a year ago, where this zero crossing point would happen, i.e. the sun's magnetic fields, polar fields were reversing, right? Just for context, that happens on the sun every 11-ish years. On the Earth, it happens approximately every 200,000 years. I'm glad that our poles don't reverse that often. The lower two panels are just looking at spatial diagnostics that we've developed, which again are statistically keyed. So there's a whole bunch of solar phenomena that when you apply this terminator to terminator metric becomes statistically well behaved. They're not statistically well behaved when you use things like solar minimum or solar maximum to characterize them. They're very messy. So panel C just looks at the progression of the global magnetic field of the sun, and you can see this pattern that, you know, starts out at mid latitudes, progresses to the poles, and then tanks its way over some 20-something years towards the equator. All right. So this is where things were. So panel C was the historical average. Panel D was the data. If I move forward in time, the sun is entering the maximum zone. I don't know. I wanted to come up with some cool kind of Top Gun type measurement for that, or some neat, catchy name for that. The polar reversal is ongoing. We're in the near zero domain, right? So you can see that it's following the statistical average in. And the images that are tracing the global magnetic field are also in the right box. So things are following suit. What does all this mean? It means that sometime in the next 6 months is going to be solar maximum. So if the present upsurge, let's see if I go back to this guy. Well, I'm going to go way back, then I'm going to have to go. So the present upsurge that's taken off right now might be the last one before max. So if we're going to hit that 200 mark, it better do so over the next couple of rotations, right? So if that's the case, batten down the hatches, right? It's going to be crazy for a couple of months. But you didn't hear that here. Here's today. There we go. Biggest flare of cycle 25 so far. We love to look at these data in very perverse ways. This is, I believe, emission from iron 16. So was that 2.5 million degree plasma? But the fact that it saturates and forms this little X pattern, that's not why they're called X flares. It's actually interfering with the grid on the camera. So it's interfering down at the pixel scale, right? So it's scattering. The light is scattering when it hits because of the wavelength and the design of the camera. It's kind of even more impressive if I look at it as a running difference image. And you see how, almost half of the solar atmosphere gets perturbed by that event. Okay. I've seen them, and I'm sure we'll see one before the end of the cycle where it affects the whole disk. Right. That one is 12 hours later you're watching for Rory, right? Unfortunately it won't be so great for Ham, but whatever. I mean, sorry, don't mean that. Right. So where are we? Solar Max. Probably maybe only as much as 6 months from now. The amplitude is 50% greater than it was anticipated, if the panel's relevant. Solar cycle 25 to date, to today, has had 21 X flares. That's 45% more than its predecessor, and 150% more M-class flares. In fact, it may be closer to 200% more. Okay, so it's been considerably more active. This means that, the ionosphere and the low Earth environment, the ionosphere, which is relevant to you guys, is energized at levels above those that we didn't see a decade ago. Okay, maybe even consistently. So I would imagine you're probably getting other than blackout times, you're getting pretty good propagation, right? So it follows this plot that I show at the bottom right-hand curve. The fun bit, or maybe not the fun bit, is that solar geomagnetic activity picks up an increase in severity and frequency after solar max. We won't get into that. We can if you want, but anticipate all kinds of fun stuff happening when we get into the declining phase of sunspot cycle 25, because sunspot cycle 26 will start to interfere with it, right? Because it's a big interference pattern. Anyway, so based on where we're at, it looks like our newer approach, based on understanding this underlying 22-year magnetic activity cycle, is really showing great promise in forecasting, how the geospace environment evolves, but also how the sun evolves in time. So, and with that, I think I see 3 questions over above. I'm done. I'm going to leave that up for now. But so we can. I told you it would be quick, Paul. I have no idea what the time is.
You're muted, Paul.
Okay, I'm unmuted now. I was trying to do it with my keyboard, which is kind of dumb. Anyway, that's really great, Scott. You awesome stuff, and the world's not going to end, so that's a good thing.
Not yet.
I'm sure we got lots of questions, and I'm sure the charts that you showed are awesome. These X flares, 2.8 is for those who don't really understand it like me, what's kind of a high end of of an X flare? Is it like 3 or 10 or what?
When I was working at Goddard on console with the spacecraft, there was an X40,
Yeah,
right? It went off the scale. In fact, it saturated the detector, right? So we actually really don't know how high it went. There's speculation it could have got up to X70. That's how big it was. This was in the fall of 2003. This
wow.
is the so-called Halloween storms, right? There was several monsters that week. Not fun if you're dealing with a spacecraft.
I'm sure. Maybe the space what do we call it, the space lab up there.
Yep.
Probably not a good place to be when that happens. If you're on the wrong side of the earth. Yeah. So this is just so you know, I don't think you follow ham radio as close as I do. We've had some pretty good openings on 6 meters. Like about a week ago, I was working with about 20 guys in New Zealand, and a bunch of guys in between, which is not, that was what we considered F2. At least some folks call it F2 propagation, which we don't see very often. So we're wondering if we're going to see more of that F2 propagation as we get closer to the maximum. That's kind of what we're hoping, so we can start working around the world on 6 meters and a little dipole.
Yeah, you need that thing to bake a wee bit more, right?
Yeah. So can you just do something with that and help us along?
Oh, we could go all Spinal Tap on it and turn it up to 11.
Just turn the knob a little, okay?
Okay.
All right.
I believe the dial goes to 11.
Yeah. All right. Good. Come on, guys. Ask some questions here. We got a bunch of guys on.
I see Peter's always first, right? So Peter goes with the tough question, right? So as the sunspot cycle starts and evolves, do you know if there's any change in depth of the magnetic activity with respect to the interior of the sun? Peter, come on. All right. Yeah, so big mystery. The big mystery is, where is that magnetic field anchored in the sun's interior?
Yeah, exactly.
Right? We think it's like we basically interpret sunspots as being the tip of the iceberg. Right? And they could be anchored to systems that are hundreds of thousands of kilometers below them. Right? Hundreds of thousands of kilometers below.
Okay, interesting.
Right? And they're basically like herniations. Right? So what happens is these systems become unstable and they herniate a little piece of magnetic field off them, and that rises through the sun's ocean and pops out of the top like a spot. Right? So we're currently doing experiments to try and figure out. So the outer 30% of the sun's interior is like an ocean. And we think that we hypothesize that those magnetic fields are sitting at about 74%-ish of the interior, right? They're just sitting at the bottom of this ocean. But it's very tough. That's a very tough job. So
we still don't know. Bottom line is we still don't know. It's within some range, but we don't know what it is.
Well, and to be really
does
honest,
it change? But does it change during the cycle? Do you know if that happens? That's one of my questions. And in essence, my question: does the depth of activity? Do we know if it has any change? I mean, everything we're seeing is, call it surface. So it's best 2-dimensional, if you like, with time.
Right.
But with the depth, I'm just wondering if the pattern changes with time.
We think it does, right? And that would explain the range of diagnostics that we see, right? There's I only showed a couple of the diagnostics. So those of you that have been on this thread for a couple of years have seen the whole kitchen sink, right? I could bore you to tears with the 50,000 things that line up with this Hale magnetic cycle, right? So, but yeah, we think that there is an evolution with depth, right? That there's circulation going on inside of that ocean. But the magnetic field, the difference between the kind of textbook sun and our sun is that the textbook sun, just the magnetic field's along for the ride, right?
Yeah.
Our sun, the magnetic field is actually determining the flow, right? It's if I can say, fucking with the flow, right? It's of significant amplitude that it can change the energetics of what's going on with the convection. It's not just a tracer, right? Because I don't know how you can explain an event like the Terminator, where within one rotation of the sun, the whole thing changes, right? If those magnetic fields are just little passive tracers of some global scale circulation, you can't explain that, right? The sun's magnetic field changes all the way out to the end of the heliosphere in the space of a few rotations. That's a mind-boggling timescale, right? Nobody
And
believes
it's
the sun
also a
of that.
mind-boggling physical scale that it can change so quickly over such a vast volume of space.
Yeah, exactly.
Mind you, the
Yeah.
sun is but an ordinary star. I know that that's your specialty, of course, is the sun, but how does this compare with other stars
I
in
have
that
a sneaky,
Hertzsprung-Russell sense?
I have a sneaky suspicion that other stars work just the same. You're just not measuring them right. Right. So I think the key is to measure the magnetic activity of other stars, not the sunspot activity. Because if you think about it, what I'm basically saying about spots is they can mislead you. Right? It's a bit of a red herring. But if you measure the magnetic field, you get it spot on. Pardon the pun, right? But like the problem is magnetic field, because of my countryman and his stupid laws, right? The magnetic field div b equals 0. And so unless you're looking pole on at another star or at some high inclination angle, you're only going to see 0. Right? So you have to be really crafty when you look at that. So you've got to find a subset of stars in the sky that are significantly pole on, right? That but are also like the sun. And then actually it's the kind of cool experiment to do. Do they all have magnetic cycles like the sun? Or are they slight variants of that? And can that variation then explain? Because I would bet that if the sun spun like Jupiter, for example, which is a failed star,
Yeah,
right?
failed star. Yeah.
It would have more bands per hemisphere. And so the interference pattern would be very complex. In fact, in some of those, you might not see a cycle as such, but you may get huge frickin' flares, right? So anyway, it's all speculation, but that's kind of where I would, if I was going to design that experiment to run next year, that's what I would do.
Okay. Thanks.
Scott, this is Ken W9GA.
Hey,
And
Ken.
in context with your comment about when these local maxima of flux and number count occurs, what concerns me is the fact that these maxima and minima seem to be occurring at times which don't line up with what are considered the optimal windows for high frequency F2 to occur. In other words,
Right.
heading into the month of November, December, which should be the optimal months for F2 to occur, the numbers tank. And then if they come back and peak in June, well, that's not an optimal time. I think that has to do with the geometry of the Earth and the sun for heating up the ionosphere. Wonder if you might know a little bit more about that.
I think the sun's just jacking with you, Ken.
I would agree with that.
Yeah, it's just jacking with you. It wants you to go all excited and the ionosphere gets all nice and baked and ready to go, then wet balloon, right?
Yeah, and I noticed it's kind of like a storage battery. You've got to have flares and good numbers for a little while to actually get things to start cooking. And once it's there, it start dropping off. But the F2 may hang around for a while because the storage battery hasn't quite lost its charge.
Yeah, it's like a big capacitor.
It
right?
is.
There's like it's got a huge amount of energy storage in it. Yeah. So this is why I want it would be kind of cool to get, another big upsurge so that, you
If it
get,
could happen pretty quick, we may still have hope for this particular season then. That would be nice.
yep.
Cross your
And
fingers.
yeah, that answers the kind of question that just popped up last. So I think I don't know, 200 would be awesome. Right? But yeah, you don't know. I think it's hard to have a crystal ball. I mean, I think our forecast reaches up to 200. I think it's the median's about 190 at peak, but it's got quite a variance on it. So, you never know. That would be pretty awesome. I think that would blow the other forecast right out the water.
Yeah,
Right.
and I also think that there are a few paths, more of the southern paths, that can open with somewhat lower numbers in the peaks. The South American openings and some of the Africa and South Pacific openings. I mean, up here in the upper Midwest, we've had some decent openings to ZL, which actually lasted for, a half hour to an hour and a bunch of stations. And clearly that was F2. But as far as the Europeans contacts or the Japanese path, I haven't seen much of that at all.
Right. Yeah, I think there've been very small windows to those, right? I think probably late in the fall or like the middle of the late summer, early fall. So, but yeah, no, I'll keep my fingers crossed, right? I think there's a create for hams as well as people trying to slay dragons. Right. So I see Lance's question. A double or a single peak. Lance, you've been following along with me for 2 years, right? The two hemispheres are still well synchronized.
Oh.
Right. I didn't show the plot, but in the last few months, the activity has kind of remained in the north, but died off in the south. So the lull has kind of come from the fact that the south has retreated a little bit. So whether or not it'll stay locked in phase or not, I can't tell you, right? I'm still thinking that probably a single peak, but it just really is how you average the data, right? It's kind of like, well, if you take a 13-month running smooth through it, I mean, you just obliterate the data. But other than that, I think more cycles than not are double peaked, right? Because the two hemispheres are never quite in full synchronization. So,
Thank you.
and then Frank has to stir the pot. Do you want to ask your question in real time, Frank?
Sure. So there was a new paper just came out in November with regard to from, I don't know this group, but from India. And I believe it's basically an AI approach as opposed to, right? So it's pattern, trying to track patterns as opposed to understand it. But it correlates with what you were saying. So so that led some credence to the fact that maybe that they've got something there, but I thought you might have seen the paper and can comment.
Yeah, it's funny. If you look at the primary protagonists and making those blue predictions in the earlier plots that I showed, they're from the same group. I think at some level there's some face saving going on. Right? So they're now adjusting their prediction from the middle of 2025 back a year. Right? And the window of the amplitude is moving into our window. Right? Which I think is all well and good when you're 6 months away from it, but try doing that 3 years ahead of time. So does that make sense? So yeah, I read the paper, bit of a nothing burger. They publish a lot in monthly notices. I don't really notice monthly notices.
Well, if it works for next cycle too, we'll have a better feeling for whether they have something there, right?
Absolutely. I think that what they're trying to do is still be in the game for the next prediction of the next cycle, if I would be honest. So good luck to them. So thank you for bringing that up. I see your hand up, Peter. Are you going to skewer me with glaciology?
No, actually, it's going to be about Mars.
Oh, no,
noticed the
Mars.
paper. I noticed the paper in, I think it was one of Nature publications just this week, or within the past week, that there was a period of recently when the sun basically was really quiet unexpectedly. And they discovered with satellite data monitoring Mars that the atmosphere of Mars suddenly expanded. Like it almost became, it went from like, let's say, a few 100 kilometers thick to over 1,000. Just during this period when the solar wind was weak. And I'm just wondering if we've ever experienced the Earth's atmosphere, not the magnetosphere, but the atmosphere changing shape with the activity of the sun.
I don't know. I mean, the reason they noticed that with Mars this time is because they actually have a satellite measuring it, right?
Yeah.
So then I think that came from the Maven satellite, which is really amazing. Actually, there's so much. I think it's cool to call it unintended science that's come from putting a satellite in that orbit around Mars. It's really cool.
Yes.
So I hope that they can keep it going for another, 5 to 10 years. But yeah, no, I don't. The thing with Mars is it's an exosphere, really, right? It's not really an atmosphere.
Yeah, I mean, the gravity is a lot less, so that makes things quite different in terms of
I feel
capacity to the planet.
I really feel sorry for the Martians. They had if they had a core magnetic field like us, maybe they'd still be kicking around.
Yes, well, maybe we came from there. Ha ha ha.
Ah! Is this going on YouTube? No, but it's fascinating. I think they're learning so much about the Martian atmosphere from Maven and being able to measure things like the total solar radiance and things from that orbit.
Mm-hmm.
They're looking at really beautiful occultation stuff through the atmosphere of Mars, and which is how they kind of make these determinations. And it's really cool. I love to see missions like that accomplishing science that it wasn't designed to do, right?
Mm-hmm.
So it's like me 20 years ago, I used the solid state recorder on the center of our spacecraft as a cosmic ray detector, right? We've got a spacecraft the size of the Magic School Bus out there, 1.5 million miles away. So it's a perfect the very expensive 2 gigabyte solid state recorder that was purchased in 1986. So you can imagine how much that cost. Is a beautiful cosmic ray detector.
Mm-hmm.
So anyway, it's a great question. I see one here. How much more accurate have predictions become with time? I'm assuming, Pat, you're talking about sunspot cycles. Not really. One shoots high, one shoots low. The predominant thing I think that drove the low forecast of 25 was this 30-year downward trend. Right? I kind of hinted at it at the start that over the last 30 years, it's been going down by like 15% per cycle. And I think they get lulled in. And I must admit that 2 years before that, I also got lulled into that. But that's before we actually looked at the data in any great detail. So I wouldn't say they've become more accurate, but maybe in a couple of years I'll be able to say yes, there's at least one accurate forecast. So
based on the last, like you say, the downward trend, does this cycle 25 tell us now we're on the upward trend, maybe with one data point?
Oh, with one data point for sure, right? I'll get in trouble with Frank if I say too much. So no. I think so. What we've learned, Paul, and this is a really kind of dumb statement, but it's maybe also profound. The sun wants to be at the average. right? It really wants, so I think what we're seeing is an oscillation around the average, right? If you think about it, what we're seeing is it's like a ballet almost between these large scale magnetic systems. When they're in perfect balance, we get no spots, right? You would get into this perpetual solar minimum state. But I think what we're seeing is when we see the manifestation of spots and then activity, it's to do with the amount of asymmetry or imbalance in the system. So it's almost like, remember what I said about that Scottish physicist and his laws, right? That magnetic field always wants to be in balance, right? It kind of has to be by nature. And so I think what we're seeing is a sloshing, right? I mean, I want to make it sound way more dramatic than that, but I think that's what it is. So it just sloshes around the average. And in doing that, you get multiple cycles out of it, right? So there's this thing called the Gleisberg cycle. Anyone that's, Peter McKinnon will know about the Gleisberg cycle, right? That's this thing, this modulation that sits over the sunspot number with a period of about 80 years, right? So every 8 cycles, there's like an envelope. And that looks like it's a hemispheric slosh. So it's like everything's in balance, except it's just slowly teetering and tottering back around the medium, right? It's very small amplitude. It's a few spots per decade, but it's there, right? But then there's more dramatic periods where you get no spots, right? Like the Monte minimum and
Monte minimum, yeah.
the Dalton minimum, and those are a real freaking mystery. That's what Peter and I need to talk about. We need to talk about chasing after energetic events in the 17th century.
Using ice core data for those who are interested.
Yep. Or corals,
Yes.
or shells, or whatever we can get our hands on.
Yeah, paleo data.
Yeah. Anybody want to come with me to the Admiralty in London and digest all those ship's logs?
Oh, yes.
Yeah, that's where I'm going. I'm going to
Well,
go
actually,
hunting.
Roy Jenny, I don't know whether you would know Roy Jenny, Scott. He worked at NCAR back in the 80s and 90s. Roy and I actually did a project at one point where we were compiling bucket temperatures from the ship logs using the Cray at NCAR.
Oh,
and
wow.
So that data we had it at NCAR at the time.
All right. Well, maybe there's something
Maybe
floating
you don't
around.
have to go to the Admiralty.
Yeah, but the thing is, I think it's a lot of this stuff's going to be what's the right word? Auxiliary data, right? It's someone on the crow's nest reporting that there's an aurora on the horizon.
Oh,
right?
yeah.
It's like I want to know if there's sub 40-degree aurora.
Yeah,
Sub
right.
20-degree aurora. Where are they visible from? Because I have a hunch about how this damn thing works. But if it works the way I think it was, there must have been pretty profound levels of activity leading into it, which should be documented.
Would
So,
St. Elmo's fire have anything to do with solar effects in terms of its implications to the atmosphere?
oh, probably.
Now,
Probably.
there's another thing you would get from ship logs.
Yeah, I know, probably. I think there's a lot of geoelectric circuit stuff that we don't quite understand, right?
Well, even like magnetotellurics, which are currents flowing in the lower mantle, the lower crust, upper mantle, are induced by solar events.
Yeah, no, there's some real hardcore physics in there, or geophysics, I guess.
Yeah, geophysics. Yeah, I worked in magnetotellurics.
So somebody asked about cycle 26. So continuing this thread, the best I can say is average. But I think that probably about a year from now we'll be able to see it right? In its fledgling state up at about 55 degrees latitude. And again, if I call then my then 17-year-old to recall her finesse in drawing straight lines, I will challenge her to draw the straight line through the data and see where she thinks it's going to appear, because that is kind of indicative of what cycle 26 is going to look like, right? So if it appears next year and it looks like it's going to be average, then cycle 26 will be average. So unless we get something catastrophic happening in the tail end of 25, I would bet that it's going to go to the mean, which means that we're just, again, in this oscillation around the mean. So anyway. All right, Frank.
What one comment, Scott, as a ham, but one who's worked with you and tried to learn from you, the most fundamental thing that ham radio can learn from your team's work and your work like this to educate folks is the shift between the small number of sunspots and the high number of sunspots as our benchmark to that difference between the terminators, that simple shift. And I've given a couple of talks to ham groups, you've given many, and it's very hard to shake the barnacles off of that ship. And that was my comment.
Yeah. No, and it's not just amongst you guys, Frank. It's in my own community too, right? It's like, and when my colleagues and I talk about this, it's unclear what it will take, right? You know, you can't get more graphic demonstrations of the fact that it's like someone just hit the start button, right? If you look at solar minimum, please tell me when the start button is hit, right? It is a human defined thing. It's actually literally defined by a committee sitting around a table, and you apply whatever smoothing parameters to the data and you try a whole bunch of them. I mean, it's not physical. I think what we've got in the Terminator event and what the way we try to communicate it is it's an actual sea change. It is a physical change in the atmosphere. And I think part of the reason why it's kind of being ignored is because of the implication, right? If you acknowledge this event exists and it's like a fundamental flipping of the on switch, right? Then you get big problems, right? Because your prevailing understanding of how the interior of a star works is probably wrong, right? Which means that your cottage industry, your 5,000 students that you've taught, all have the wrong idea. Every textbook has the wrong idea. Every YouTube channel has the wrong idea. That's pretty soon there's real money, right? As some senator said sometime.
Scott, we tried to make the point in the paper in Radcom that the long-term observables, going back to the original observation, is not the thing itself. It's the realized end or near end of a process. And it's that unobserved process that we're trying to discover. And yet we tend to focus just on those numbers. Why? Because they're available. You know, they're available.
Well, you're absolutely right, Frank. I mean, an old mentor of mine, one of my PhD, I had 4 PhD supervisors, just, you know, one's not bad enough, right? But tremendously amazing folks, all of them. And he said to me, until you have something better, you're never going to be able to replace it. Right? So the sunspot number has been around for 400 years. And it's something that everybody's been trained on. And until we have something better, and it's categorically demonstrated that it's better, it's not going to replace it.
This is why the AI paper, I made the symbol, just shoot me now. Because we desperately need 5 more models that have zero theory in them, but just have a bunch of penguins in an equation. That's really what we need, right?
Correlation.
But you guys have a theory, and that's the thing I've harped on in ham radio. We finally have a theory that's out there. 2 models that are equally explanatory. One has a theory, one doesn't. Which one is stronger science?
Right. Well, and so far, I would say that the concept is holding out, right? So, I mean, the fun thing, so it didn't talk about this, and maybe, Paul, for the next talk, I'll give a talk focused on what happens when the sun switches off, right? The Terminator event has a counter event, right? And you know, for those of you that are familiar with the Terminator movies, who's the progenitor of the Terminators? There's a guy called Kyle Reese, but there's also James Cameron, who was the director. So we call them the Cameron events, right? Because, you know, we're stupid that way, right? But there's a progenitor. There is another event on the downside of the sunspot cycle. Again, when the solar flux passes through 90, where the sun makes no spots, right? There's, like I showed in a lot of the plots earlier, there's 4 bands present, but the damn thing can't make spots, right? Why? Because it's now in this logjam state where there's a whole bunch of Maxwell's equations going on, right? There's a whole bunch of cancellation starting. And it takes another 6 years to break the logjam. How does it break the logjam? With the Terminator event, that the 2 nearest to the equator die, right? And the funny thing is, Frank, that to me, the Cameron, this kind of Kyle Reese event on the downside is far more illustrative of the fact that these magnetic systems interfere with one another than the Terminator event is. All of a sudden, you just don't make anything complex, right? But it's not just this cycle or last cycle. It's the 23 previous ones that do it too, right? So it's kind of like, you know, it's fun because, again, Paul, next time I'm on, I'll focus on this stuff. Just like the butterfly pattern starts with the Terminator, it stops with the Cameron, right? But the magnetic fields that produce the spots are still there, right? They're just not making spots because you've now entered this different domain where things are canceling and you're effectively in solar minimum conditions, right? For however long that takes. So I think we learned a lot in getting our Terminator forecast wrong. I think we're going to be accurate to within a few months next time. Right. And that could be scary I think that's when we go to Vegas. So Frank, if we pick out a hotel to go dance on the top of, and then we're going to put a shit ton of money down on black, right? And the folks in Australia, we're going to tell them that they're going to have an El Nino and there's going to be a bumper wine crop, and we'll start buying up wineries in Australia.
And the statistician in me wants to point out your error in estimating the subsequent Terminator actually confirmed your theory.
Right. Right. Unfortunately, my colleagues don't think of it that way. Anyway, thank you.
All right. There's no other questions. Maybe we'll just thank Scott for spending the time tonight and appreciate you coming back. What we'll do is when you're less busy, which is not very often, I'd like to have you come on back and give us another update. Maybe when we hit the peak, you know, or at least when you think we've hit the peak, give us
in the spring sometime.
Yeah, just give me a ping or a call or something like that, and we can schedule another time, and you can show some more of those beautiful charts of yours and tell us what's going to happen next.
Yeah, I'd love to talk about the death of the cycle.
Yeah, you know,
I know I know it's not as much fun for you guys because that's when we drop below 90 and the ionosphere goes, it mocks you from afar, right? But, I think that it's fascinating because it's telling you about the physics of what's going on inside that object, right? And yeah, I can't wait right now. I think our forecast of that event is the third quarter of 2027. So we've got a while yet.
Yeah,
So
that's good. Yeah, we'll at least have a few more years of good 6 meter activity.
and teasing.
Yeah, when the minimum comes along, we'll still be doing EME. So
Right. I see Peter still has his hand up. So Peter, last one, and then I'll free you all from my dirge.
Yeah, it's okay. I'll wait now. It's Scott. No problem. I'm looking forward to hearing from you.
Yeah, we'll talk about ice cores because I need some guidance. Okay.
Okay.
very good. All right, guys. Thanks again for everybody joining us. And we'll be redoing this on YouTube. And another one of those fascinating Dr. Scott McIntosh's stories about the sun.
Thanks,
Thanks,
guys.
Scott.
I appreciate your interest, everyone. Take care. Have a happy holidays.
Happy holidays.